So the example is solve this absolute value inequality. Absolute value of 3x plus 2 minus 4 is greater than or equal to 0. And we want to answer in graph, interval, and set notation, set form. Solution, let's write the problem here. Absolute value of 3x plus 2 minus 4 is greater than or equal to 0. So we're going to look back at our notes, and that the note we're interested in, we are going to determine it by which direction the inequality sign is pointing. So we had seen a note that said when the absolute value of some expression, capital X, is greater than or equal to a number C, that means, it means exactly the following: that the stuff inside capital X is less than or equal to the negative of C, union together, don't forget the union symbol, union together with the stuff inside the absolute value, capital X, is greater than or equal to positive C. And a way of remembering this, just so you'll remember how to start this first expression without the absolute value bars, is to remember for an absolute value to be greater than a positive number, C, it means that, let's say 0 is here. This is C units away, and this negative C on the number line is C units away. It means it either has to live in this interval or in this interval. So this is what we need to be able to eliminate the absolute value symbol. Alright, so let's apply that here. That implies the stuff inside 3x plus 2 is, what does it say, less than or equal to. See, notice we flipped the direction of the inequality when we wrote this. We're applying this rule. It has the inequality pointing in the less than direction. Oh, I forgot that first I had to isolate. So back up here, I have to isolate the absolute value, 3x plus 2. Move 4 to the other side. It's greater than or equal to positive 4. Okay, so it's less than or equal to the negative of 4, union together with the stuff inside, 3x plus 2, greater than or equal to the positive of 4. If you try to do this as a compound inequality with the expression in the middle and some 4s or negative 4s on the outside, no, it's not true. It does not work, because the inequality sign in the question here is pointing in the greater than or equal to direction when we isolate the absolute value. Okay, so let's continue by simplifying this side and simplifying this side and work our way down. Here we have 3x is less than or equal to minus 6, and then x is less than or equal to negative 2. Okay, bring down the union symbol. Very important not to leave it behind. Here we have 3x is greater than or equal to 2 when we subtract 2 from both sides, so x is greater than or equal to 2/3. Okay, so we have the union of these two intervals. Let's do the graph. Okay, the smaller number is negative 2. The larger number is 2/3. Shade everything smaller than negative 2. Shade everything greater than 2/3. A boxy bracket on the negative 2. A boxy bracket on the 2/3. That's graph notation. Next we'll do interval notation. You have to express both of these intervals. It's called a split interval because there's two of them, and you have to join them together with the union symbol. First, we express the interval shaded on the left. The smallest value shaded is negative infinity, comma. The largest value shaded in that interval is negative 2. Open at infinity, and we get a boxy bracket on the 2 as we did in the graph. Union, don't forget the union symbol. Combine that with smallest value shaded is 2/3, largest value shaded is infinity in this second interval. Include the 2/3, never include infinity. There's my interval form. And finally my set form, curly set bracket, all real values x, such that the two conditions apply that we have in the cloud above. X is less than or equal to -2, union together, don't forget the union. X is greater than or equal to 2/3. Close your bracket. And that's your answer. All three forms of the same answer.